Welcome, everybody. We're going to just get started in a minute or so. Just give people time to kind of file in. All right, I think we can get started. So welcome, everybody. Today we're going to be talking about platform engineering and how we can start to kind of scale operations through the art of platform engineering. So chat is open, so any questions or anything, feel free to throw those questions out, and I'll get to them as I see them. So my name is Dave Williams. I'm the CTO of MassDriver, and I got into platform engineering because I spent many years kind of on both sides of the dev and ops spectrum. As a product engineer, I spent a lot of time having product engineers yelling at me saying, when's product going to be shipped? Well, dealing with kind of a DevOps backlog. And I've been on the DevOps side where product engineers are mad at me because I have lots of tedious tasks to do and not enough time in the day. And so we can solve a lot of that pain with platform engineering. So the first thing I want to do is talk about kind of what changes when you go from DevOps to platform engineering. So in DevOps, in every kind of iteration that I've seen it, we usually like automate through code, right? That's the big change that happened with the DevOps revolution, right? We write some Terraform, we write like a pipeline to run that Terraform, we check in changes, and we deploy. When moving to platform engineering, our goal is to shift all of this left and provide operations as features in software. Now, the cool thing about this is we get out of the kind of loop of DevOps where a new project starts, we need some new infra or a new environment, we write code, we ship that environment, and it's kind of like on a per project basis, right? It's not this kind of like ongoing product that we provide. As we move to platform engineering, our goal is to provide on-demand access to all of our expertise at any given point in time. And in DevOps, one of the difficulties is like training, right? Getting your engineers to understand your tooling, right? Teaching them Terraform, teaching them about Helm and Kubernetes. This is challenging because this is not stuff that is done every single day. And because it's not done every single day, this is training that goes to waste. People forget it and then have to relearn it. And it's really difficult, not just for the people doing the training, but also for the people being trained, right? It's really hard to learn things when you're not kind of practicing it every day. And as we move to platform engineering, the goal is to have like that single piece of software that unifies the experience. So regardless of tooling, an engineer has the same experience and can kind of continue to learn and grow through use of your platform instead of having to like dive into like the nitty-gritty details of Terraform or Helm or CloudFormation. So as we start to think about that shift, if you blur your eyes just right, we can see a system of consumers and producers, right? And we've built systems that handle this kind of marketplace concept. And so the approach that MassDriver's taken uses some of the things that we've built a million times in our products and gives that us a starting point to building our own platforms. Now, I'm going to use the experience of building MassDriver to talk about building a platform. And I would love for everybody here to get value from our platform. But more than anything else, that pain that I talked about being a product engineer or being an operations engineer, I want that kind of resolved And so you can steal any of the tools here to start to build your own platforms, right? To find the places where these concepts make sense and to build them internally in your org. So with that in mind, let's talk about a technical breakdown of what a platform could look like. So in a world where there are producers and consumers, we need some kind of a product. And in MassDriver, that's a golden block, right? Our bundles. Let's talk about what's in one of those, right? So they're modules that package all of the resources involved in an architectural function with a shared lifecycle, meaning they're atomic and they're like Lego blocks that encompass a concept, right? So in an example of SQS, it's not simply an SQS queue, right? It's a primary queue where you're kind of writing and reading to, but it's also a dead letter queue because like redundancy is non-optional when you care about data integrity, right? You need to write good read and write permissions, right? It shouldn't be on the user to define how to interact with this queue. It should be on the queue to say, this is how you interact with me. And default alarms, right? Like learning how to effectively monitor on the fly is really challenging for product engineers. I think using that time where you're kind of building these products to say, this is how we think you should, at a minimum, monitor these things and provide them to the customer immediately is really, really helpful, right? This could be CloudFormation, this could be Terraform, this could be whatever. We've encapsulated a concept with some tooling, right? Now we need to provide a way for somebody to interact with that. So we have a collection of schemas that do a couple of important things, right? One, provide a minimal interface, right? Users need to be able to scale their infrastructure and their applications, but they don't necessarily need to turn off security features and things like that, right? So defining a really clean API with rich validation. So before a CI run fails or a CD run fails, we should be able to tell that there's an issue with inputs, right? We need structured input and output to allow these blocks to be composable, right? We want them to be Lego blocks because they are kind of narrowly scoped. We want them to be able to connect together, right? And we use JSON schema to do that, to both define ins and outs and to define these minimal interfaces, right? And wherever we can, we try and create smarter internals, right? So think about picking IP ranges that make sense, right? Instead of making a developer learn what an IP range is for a VPC, right? We can do something like look at all the VPCs and make sure we have a CIDR range that doesn't collide with another one, right? That shouldn't be on our engineer who knows nothing about the cloud. It should be on us. So this is what you get as a result of kind of wrapping your modules, right? Whether they're Terraform or Helm in this golden block spec. You can see on the left, we have like a really small form, right? It's doing some interesting things. It's providing an enum for like regions, right? So maybe your company only uses US East 1 and US West 2, right? Shouldn't be on an engineer to go have to figure that out. We can actually provide them the tools to figure that out and keep them safe. We're doing some like data conversion, right? We're allowing you to say like 1 minute or 30 seconds and doing the conversion that like the SQS API needs behind the scenes, right? On the right here, you can see an example of like an output from this golden block spec, right? These are what we call artifacts here, but all they are is a record of like what was created, right? The ARN of the queue in this case, right? The IAM policy to read from it. We only allow read from this one. And some specs, which are some basic metadata about what we've created, right? In this case, it's just kind of telling you what the region is, which is important in the context of SQS because you need to do some extra stuff for cross region. So you might have a constraint that like the thing consuming this needs to be in the same region as this SQS queue. Now, the cool thing about these ins and outs in JSON schema is we can actually start to model our architecture, right? We can start to like put these Lego blocks together and get living documentation of the thing that we've created, right? All of this created without copy pasting any usernames and passwords, without having to copy paste ARNs in anything, right? All of this is just kind of flowing through the system and creating our infrastructure. So now that we have products, we need a way to find all of our products and use these Lego blocks, right? So in coming into an organization, it's often challenging to figure out what we're running and what we're allowed to run, right? You can imagine going to GitHub and typing in like MongoDB and hoping to find like a Terraform module in one of the repos or something like that. With platform engineering, if we're trying to kind of shift our expertise left into these blocks and these bundles, right? We need an easy way to discover things, right? We need an easy way for people to say, like, I want to know all NoSQL databases that are in my catalog. I should be able to go to the source to make sure it supports what I need it to support. In MassDriver, we do compliance indications, right? To make sure that, like, before we choose our infrastructure, we make sure that it meets our compliance standards, whether that's HIPAA or SOC 2, right? And with these models, we can actually duplicate these models many times. So our golden blocks can actually create golden paths. These can be kept in your catalog as well, right? So you could see a world where your catalog is like individual blocks, and then it's like, here's a serverless ETL, right? That has that all strung up for you, and you can make modifications as you go. So we need fulfillment now, right? We have a product catalog. We need some way of like doing something with this. And for MassDriver, that's provisioning. Our provisioners are kind of unique. We don't write a pipeline every single time we make one of these blocks. We actually have like single pipelines that can run blocks of a certain type and tooling. The nice thing about this, and the nice thing about it being kind of internal, is we actually create the state of our system and all of our audit logs by running these blocks, right? So you could imagine a block with Terraform, right? We say, hey, we need fulfillment on this Terraform block. We need this to go to the cloud. You deploy it. We can record who decided to do that, right? Any relevant metadata for your business, right? We can start applying default tags. Your CFO is going to love it if you have like your COGS tags in place immediately and correctly. We can inject secrets and dynamic configurations at runtime, right? And all of these things are based on the current state of our system, right? So the piece of software that we have to manage the cloud is actually like determining the state and the history of everything and telling us that in real time, right? Makes audit time a ton easier. Now, we need a record of all these things that we're creating, right? Like, we have that artifact that we can pass between things that contain relevant information for like connecting the Lego blocks, but there's a lot of stuff that's actually not relevant in that particular scenario. And so what we do at MassDriver, what we think everybody should do, is create an inventory or an infrastructure bill of materials, right? And this just captures every sub-resource that was created in a block, right? Creating a VPC isn't one resource. It's like 40 resources, right? It's subnets, it's IP tables, it's all of this stuff. We should have a record of all of it so we can now associate every single thing in our cloud to the resource, to the project, to the environment. This stuff is all kind of done intelligently through some plugins, and we're looking to kind of expand that offering. But this is incredibly useful because we can do interesting things with that bill of materials. We can start to compare environments, right? If two environments are at parity and we know all of the resources within the kind of blocks, we can go out and say, what are the differences between these two blocks? And we can compare each resource's configuration and spot the differences really, really quickly, right? Also makes it easy to promote changes, right? So we can say, we made this change in staging. We can compare the differences. Everything's running good. Time to up production to the same value or something like that. Okay. Next thing you can do is monitoring this infrastructure bill of materials, right? So the way that the APIs for the cloud work is metrics are kind of on a per resource basis, right? You need to be able to say, like, I need to know, what the kind of input bytes are for a database with like this arm, right? If you've recorded an inventory of all of your resources, you can go out to the cloud and associate every relevant metric to a single block, right? You can then start creating alarms. It's not much harder to say, Now, when this value goes over X, tell me something, right? This is way easier than having to do it kind of as code, right? You can create like useful abstractions to make the creation of alarms easier, right? There's some fields that are going to be more or less the same. There's ways to kind of abstract complex math and metrics. And with this infrastructure bill of materials, it's wildly easy to start putting these pieces together and getting live metrics in the same place that you monitor and deploy your infrastructure. Cost and usage is another interesting one. Cost is a thing that a lot of people are talking about. It was a huge topic at reInvent this year. And once you have this infrastructure bill of materials, it's really easy to break down your invoices and say, this is kind of what this particular cache or this particular database costs us, right? And as you record all of those values, it's really easy to spot cost trends on like the day and month level. And it's really easy to start making your own alarms, right? Outside of kind of the budgeting tool of the cloud, right? So you're not kind of vendor locked in. You can say, if this database or this environment costs more than X, I want to be notified about that. So I want to talk real quick about like the state of the art, right? I think one of the reasons for wanting to give this presentation is to talk about some of the pitfalls that you'll encounter when kind of starting your platform engineering journey or buying products, right? And I think like if you kind of look at the current state of platform engineering tooling, right, one of the big things you see is like they focus on aggregating data. They're kind of read first tools, right? Think Backstage. Backstage is very much about kind of cataloging more than it's about like doing. So if the problems in your organization are hard to find information, tools like Backstage are a great choice. If you're like, we need infrastructure faster, we need for our software engineers to kind of own their infrastructure, tools like that may not be the best, right? And I think moving to a system that creates the data as opposed to aggregates lots of disparate sources is probably the direction you're going to want to take. There's a lot of tools that are kind of like Kubernetes is platform engineering, and they're kind of wrappers around Kubernetes. But when you need to deploy an RDS database because you're not comfortable running, Postgres as a stateful set on Kubernetes, you have to do a lot of work. And that's probably going to be too limiting, right? Especially if you're not ready to fully adopt Kubernetes, right? If you can't support serverless, if you can't support VMs, you're probably going to run into a pitfall before you know it. So the kind of thing that we see is like treating the application like the center of the universe. We saw that for years, right? Heroku was very much kind of this like you use it to deploy an application. And I think before we kind of discovered event-driven systems, this was like really, really cool and really, really flexible. But more and more of our code is being shipped to managed services and SaaS vendors. In that world, like your application is no longer the center of the universe. And so whatever your tooling is, it needs to be able to treat everything kind of equally. And that brings me to the next point, which is like, is the product you're looking at or the product you're building going to break in the face of change, right? The next cool thing to come out that is wildly useful, how hard will it be for you to integrate that, right? I think who knows where computing is going to go. I hope Kubernetes is around for a very, very long time. But if it's not, how up the creek are you without a paddle? So all of these things are things you should consider when building your platform, when talking to your kind of internal customers, or when shopping for a platform. That being said, this was kind of my primer on platform engineering. I'm opening it up to any questions if there's anybody with something to ask. Doesn't look like there are any. All right. Thank you, everybody. Have a great day.